Hey there, it's Mr. Moeddin. I have a help video here on how to use a table or to create a table to answer limit questions. So we're given to this question here, which asks to find the limit as x approaches -3 from the left of some function f of x, which we have no algebraic representation of nor graphical representation of. So we have to use numbers as our means to answer this question. -3 from the left would be a number slightly less than -3. So let's try over here. Let's try -3.1. That's a little bit less than -3. -2.9 as our output. Okay, let's get closer to -3. Something a pattern. Let's get awkwardly close to -3. Okay. I'm seeing something here. I feel confident enough that the limit as x approaches -3 from the left is -3. What about -3 from the right? Slightly more than -3. Now you got to think, we're talking about a negative number here. So a little bit more than -3 to the right of -3 on the number line would be -2.9. So I'm not using the output 2.9, sort of a confusing problem here, but the x value that is slightly more than -3 will be -2.9. I get -6.41. That's kind of a weird number. Let's get even closer to -3. Interesting. Closer still. All right. So the closer I approach -3 from the right-hand side, which is to say numbers more than -3, the closer we're getting to what appears to be -6. So from one side we get -3, from the other side we get -6. Because these are different values, we can safely say the limit does not exist. What we haven't answered, and what may not be visible on the screen, is what is the value of the function at exactly -3? And we can answer that by plugging into our table here. Exactly -3. Not close to, but exactly. Well, that was a surprise. We didn't get any value at all. I thought it'd be -3 or -6. In this case, it's undefined. So it's a very funky function. Graphically, what's happening is we have a value from one side, which is -3, a value from the other side, which is -6, which I guess is actually down here. And then in between, there is no filled in dot. So there's no value for that, for which we say undefined. Let's see how we did. Okay, good for me. Let's do another one. Okay, this is investigating the number 2. Feels like Sesame Street. A little bit less than 2. 2 from the left, in other words. So 1.9. Okay. Closer still. Closer still. I'm getting 1 vibes here, so let's go with 1. And 2 from the right, a little bit more than 2. So 2.1, let's get a sense of what's happening, just a rough estimate. Interesting. 0.98, 2.001. I'm getting very close to 1 as well. 0.999998 is basically 1. So from the left, we got 1. That's the first blank. From the right, we got 1. That's the second blank. So as we approach 2, not from the left or right, we get 1. In other words, this question here is simply a summary of the previous 2. If they're the same, it's that. If they're different, it does not exist. At exactly 2, leaving aside the language of limits and just function input and output, we get 3. Okay. Graphically, what this means is from the left and the right, approaching 2, we get a value of 1. There's a hole in the graph, and where that hole is filled in is not at 1, but rather at 3. So having graphical intuition is useful, but we can do this all numerically as well. As you can see. Hope this helps.